1.6 is about the absolute value equations and inequalities. The important concept to remember here is that if you have like the absolute value of some number x equals, like say 4, like they're using, what are the possible answers for that? Well, when you take the absolute value of a number, there's always two possible answers. Absolute value of x equals 4, x could be 4, or x could be negative 4. Why? Because remember, the absolute value of negative 4 is just positive 4. Absolute value is just the distance a number is from 0. And since we're talking about distance, distance is always positive. What is the solution of 2x minus 1 equals 5? So you have to ask yourself the question, well, 2x minus 1 could be 5, or 2x minus 1 could also be negative 5. Why? Because we just talked about it could be 5, or it also could be negative 5. So you want to solve it both ways. So I'm going to add 1, so you get 2x equals 6, divide by 2, x equals 3. Big point is or, add 1, 2x equals negative 4, divide by 2, x equals negative 2. So my two answers are 3 or negative 2. Graphing the solution, especially when it's an equation, it really doesn't matter to me. You just draw a number line. This I think is completely pointless, but hey. Draw a number line, 0, 1, 2, 3, negative 1, negative 2, because it's equal to, you put a circle on it, and draw a dot. Problem 2 is solving a multi-step absolute value equation. What's the solution of 3x plus 2 minus 1 equals 8? When you're doing this, you got to make sure that you get the absolute value by itself first. You can't set this equal to 8 and negative 8 together. You got to get the absolute value by itself. So add 1 to both sides first. Again, reverse order of operations. 3 absolute value of x plus 2. That was terrible. Equals 9. Divide by that 3. So I get the absolute value of x plus 2 equals 3. So again, this is now where you have your two answers. So x plus 2 could equal positive 3, or x plus 2 could equal negative 3. Subtract 2, x equals 1, or subtract 2, x equals negative 5. When you have variables inside and outside the absolute values, you really need to check the solutions to make sure they work. So when we're doing this, you still set it up the same way. 3x plus 2 equals 4x plus 5. So you rewrite the equation again. Or 3x plus 2, which is what's in the absolute value, equals negative of 4x plus 5. And then you solve. I would subtract 3x first, so I get 2 equals x plus 5, subtract 5, x equals negative 3, or, now, you got to distribute the negative there. You get 3x plus 2 equals negative 4x minus 5. Where's my smaller x? Well, negative 4x is smaller than 3x, so I'm going to add 4x to the other side. That gives me 7x plus 2 equals negative 5. Subtract 2, get 7x equals negative 7. X equals negative 1. So since there's variables on both sides, let's check. Does the absolute value of 3 times negative 3 plus 2 equal 4 times negative 3 plus 5? I'm not even going to mess with the absolute value. Go ahead and put this in my calculator. I'm going to end up with negative 7. When you do this, you end up getting negative 7 too. Just punch it in your calculator. Is the absolute value of negative 7 equal to negative 7? And you know that can't be true, because when you take the absolute value of a number, it can't be a negative distance from 0. Well, what about negative 1? Let's try that one out. Absolute value of 3 times negative 1 plus 2. Does that equal 4 times negative 1 plus 5? Solve it out. I get the absolute value of negative 1 equals positive 1. Now, does the absolute value of negative 1 equal negative 1 or positive 1? Yep. So the only solution to this problem is actually 1. Now we get to solve absolute value inequalities. So I have a little key here. less than, greater than. So if it's a less than sign, it's an and, so less and. If it's a greater than sign, greater, so it's an or statement. So what do I mean by that? Well, we just talked about it. Less and greater. So 2x minus 1 is less than 5. Okay, and we talked about how to write it earlier. 2x minus 1 less than 5. Rewrite it. And, minute you have and, put it in the middle. Greater than negative 5. So how do I go about attacking this one? Add 1 to both sides. That's both sides. Oh, wait. Technically, you have a third side. So add it everywhere. So I get 2x less than 6, which is also greater than negative 4. Divide by 2. Well, I've got to divide everything by 2. Negative 2 is less than x, which is less than 3. Graph it. Draw your line. 0, 1, 2, 3. Negative 1, negative 2. Open circles. Shade between. Now here's a greater than sign. So remember, less and, greater. Less and, greater. So again, start off writing it the same way. 2x plus 4 greater than or equal to 6. Well, it's greater than, so it's an or statement. 2x plus 4 is less than or equal to, and again, change the sign. So let's start. So 2x greater than or equal to 2. Divide by 2, x greater than or equal to 1. Or, same thing, subtract 4, 2x less than or equal to negative 10. Divide by 2, x less than or equal to negative 5. Graph. Zero, 1, then 1, 2, 3, 4, 5, negative 5, greater than or equal to, close circle. You really just have to kind of box in so you see it's shaded all the way up there. Less than or equal to, close circle, shade the arrows.